Conditions for quadrilaterals. Given the information marked on each figure below, select all classifications that must be true. Note that each figure is drawn like a rectangle, but you should not rely on the way the figure is drawn in determining your answers. If necessary, you may learn what the markings on a figure indicate. And if you don't know what the markings are, let's go ahead and click on this. So first we have these tick marks, which they call slashes. These indicate congruent sides. So 1 to 1 shows that those sides are congruent. 2 to 2, those sides are congruent. Same thing with arcs. So you have 1 arc to 1 arc. These indicate congruent angles. So 2 arcs to 2 arcs indicate 2 more congruent angles. And then the arrows, these indicate parallel lines. And again, you just match 1 to 1, 2 to 2. And then the last one and this one is a square. So this square indicates that it is a 90-degree angle or a right angle. So those are the markings really quick. And we do need to understand the markings because like it said, all the figures are drawn to look like a rectangle, but you can't rely on what they look like. You have to rely on the markings. So we get 3 questions here, and it just says mark all that's true. So make sure you mark everything that can be true. So down below, a quadrilateral is a 4-sided polygon. So if you click quadrilateral, which you should click quadrilateral pretty much on every single one, because if it's drawn like a rectangle has 4 sides. And that's all we need to call it a quadrilateral, is for it to have 4 sides, okay? A parallelogram is a quadrilateral with 2 pairs of parallel sides. So 2 pairs meaning left and right are parallel, top and bottom. So left and right is 1 pair, top and bottom is another pair. So if it's indicating that it has 2 pairs of parallel sides, you can say that it's a parallelogram. To step down into rectangle, we need to make sure that it meets the conditions for rectangle. So first, let's go over a couple of conditions for parallelogram. So condition 1, it is a quadrilateral with both pairs of opposite sides congruent. So if we can see that both pairs of opposite sides are congruent, so we can see here 1 tick mark to 1 tick mark from left to right, those are congruent. Top and bottom have 2 tick marks, those are congruent. So that's 2 pairs or both pairs of opposite sides are congruent. Another condition is that a quadrilateral with both pairs of opposite angles are congruent. So opposite angles just means you go from vertice across to the other vertice. So you don't want to go straight down along a side, you want to go through the middle. So those are opposites. And as long as both pairs of those are congruent, you can say that it's a parallelogram. So if I have, these are conditions that are separate. So if it shows me the sides, then I can say it's a parallelogram. If it shows me the angles, I can say it's a parallelogram. If it shows me both, that's just overkill. It's more than I need, but I can still say that it's a parallelogram. So the third condition is a quadrilateral in which the diagonals bisect each other. So that means they cut each other in half. Bisect. So this means like there's a midpoint here. Here's half of this diagonal. Here's the other half. And here's half of this diagonal and half of this diagonal. So the 2 diagonals literally chop each other in half. And then the fourth condition is if a quadrilateral that has at least 1 pair of opposite sides that are both parallel and congruent. So this shows you have parallel arrows on the top and bottom. You also have a congruent tick mark on the top and the bottom. So if the same pair is both parallel and congruent, we can call it a parallelogram. So we have to remember those 4 things. That's important. Opposite sides, opposite angles, diagonals bisect each other, and there's also this other special one, like I just said. 1 pair is both parallel and congruent. Now we can talk about rectangle. So a rectangle is most commonly defined as a rectangle, a quadrilateral with 4 right angles. So that's the first thing. It needs 4 right angles. And then there's also these other conditions down here that can also help us determine if it's a rectangle. So it is a parallelogram with 1 known right angle. So I'm going to open this up. I was going to use that Venn diagram from one of the other videos, but we need to be a little bit more specific on rectangle for this one. So it has 1 right angle. And it's showing you it's a parallelogram because it has these parallel marks. Well, opposite angles of a parallelogram are congruent. And also, consecutive, one right after the other, add up to 180. So if this is 90, then for these two to add up to 180, I need another 90 here. And then we could go across, and that would be a 90. So if I have one right angle and it's a parallelogram, then we can call it a rectangle. It is a parallelogram with congruent diagonals. So again, we can prove it's a parallelogram, and it tells us that the diagonals are congruent. So in this case, they cut off the letters a little bit here, but A, D, and C, B, like this, going across. So from top to bottom, and then bottom to top here. All right. The third condition is a quadrilateral with 4 congruent angles. So if they're all congruent, then they have to divide it up. And every quadrilateral, which we've gone over this a few times for the sum of the angles of a polygon. So every quadrilateral, all the angles add up to 360 degrees. And that's anyone, not just a rectangle. So if they're all the same and you have 4 and I divide by 4, then I get 90s. So that's why if we know they're all congruent, they all have to equal 90 degrees. All right, and then the fourth condition is a quadrilateral with at least one right angle and all other angles congruent to each other. So it's showing one right angle. So we have one little box that's showing a right angle, and all the other ones are congruent. We don't necessarily know it's a parallelogram in this case. It says it's a quadrilateral, but I know opposite angles are congruent. Or opposite. Let's see. Why? I want to make sure because it's not a parallelogram, so I don't necessarily know right off the bat. So I may have to cut this part really quick. Okay, so we can see the one right angle down here, like this. And then we have these other 3. So this actually, and you can click on these Y features too. It actually goes through and explains some of this. So I know that they all have to add up to 360. I already said that. And that's going to equal these 3 angles, which I'm just going to call X for now. So I have 3X, and I also have 90. So if I subtract 90 like this, then I end up with 270 equals 3X. 90 minus 90 disappears, or not disappears, sorry, cancels out. Divided by 3. So 270 divided by 3 is 90 degrees equals 3 divided by 3 is 1, so we have X. So each one of these X ends up being 90 degrees in this case. So this is a way to be able to prove it. So if I'm given 190 and all other angles congruent, I know that it's a rectangle. And if I can call it a rectangle, I can also say it's a parallelogram. So it's one of those things, if I click rectangle, I better click the other 2 as far as being true. So down here you can see it's a quadrilateral and a parallelogram. So if I click parallelogram, I better click quadrilateral. And if I have rectangle, if I can prove rectangle, I've already proved the other 2. It has to be a parallelogram, which is also a quadrilateral. And this one, all we can do is parallelogram, and we know it's a quadrilateral. So we just have to make sure we click all the ones that are true. So let's go ahead and get started. Okay. So with this one, I can see opposite angles are congruent. So I can see this one from top to bottom here, and then I can even change my color here for the other 2. So I have bottom to top there. So I have B is congruent to C, A is congruent to D. So this is opposite angles are congruent. So right away, I know it's a parallelogram. I can also see it's 4 sides. So I'm going to say quadrilateral. All right. So in this one, I have 1 to 1 here going along the side, but they're not opposites. So I can't really say anything about this one as far as parallelogram goes. But I do see it has 4 sides, so it is a quadrilateral. Remember, in order to do the sides, it has to be opposite sides congruent. And if I go opposite here, these are not marked as congruent. They look congruent. Don't trust the diagram. They're not marked that way. I can't say that they are. All right. And then I have two 90s here, and I have no markings really to show me that this is a parallelogram. But I have one 90 and another 90, and then these two are congruent. So if I go over here and I do my math, remember they have to add up to 360. And then I have two 90s here, so 90 plus 90 is 180, equals, oops, sorry, not equals, plus, selling me, plus, and I'm just going to call these x and x, okay? So I have 2x. I'm going to subtract 180, which I'm left with 180, because 360 minus 180 is 180. 180 minus 180 is 0. And I bring 2x down, and I'm going to divide by 2, and I end up with 90 equals x, because 2 divided by 2 cancels. So I just proved that they're all 90s. If they're all 90s, then it's a rectangle. It's quadrilateral with all 90s, and that means it's a parallelogram. So it's all three. So I can go check, check, check. All right, so we should be good to go. Yay. All right, let's clear this and do the next one. Here, let's change our color up a little bit here. We'll go with purple. Okay, so this shows me I have these parallel marks. So I have parallel, so 2 to 2. And then we'll go with pink on the top here, pink. So 1 to 1 for the top and the bottom, and 2 to 2 for the left and the right. So I know it's a parallelogram already. I have two pairs of parallel sides. I also know it's quadrilateral because I can see that. And you should check quadrilateral on all of these because they already told us it's drawn to look like a rectangle. Rectangle's 4 sides. So now we just need to be more specific in here. And so now I can see these congruent marks on all these diagonal halves, or all these diagonal pieces. So it's showing me that this is a midpoint for ML because it's cut in half. It's also showing me this is a midpoint for KN because KO and NO are also congruent. So it's cutting them in half. And they're all congruent to each other, which means that the diagonals are congruent. Diagonals being congruent means that it's a rectangle. All right. Now I have 90 and 90. I have no other marks. I just know it's 90 and 90. I don't know that it's a parallelogram. I don't know if these are the same angle. We could have 89 and 91 here. I'm not sure. They haven't given me enough to be able to go through and say what these angles are. I can say that these are parallel. And the reason I can say that is consecutive interior angles add up to 180 degrees. So I know that these two are parallel. But I can't really say anything about these ones because I have nothing to go off of for these other ones. So all I'm going to do is quadrilateral on this one. This last one we have, if we go opposite sides, I have 1 to 1, and then I can go left to right here, and I have 2 to 2. So opposite sides are congruent. I know that is a parallelogram. All right, let's go ahead and click all of these and check. Okay, one more. Clear. Okay, so again, we should start off with at least checking quadrilateral on each one of these. So I already know that. Now this one, I can see opposite angles are congruent, but I can see a little more than that. It's not just opposite angles, they're all congruent. And remember, if we go through, they have to equal 360 because it's a quadrilateral. If I divide by 4, I get 90 degrees. Well, if they're all 90 degrees, then it's a rectangle. And because opposites are congruent, or because it's a rectangle, I can say it's a parallelogram. All right, so this next one here, we have left and right are both parallel and congruent. This was the 4th special condition for a parallelogram. So this is one that we just kind of have to remember because it's one of our special conditions. If one side or a pair of sides is both congruent and parallel, then we can say that it's a parallelogram. All right, now we have these marks here. So we have top and bottom are parallel, and we have left and right are parallel. So we know it's a parallelogram because we have 2 pairs of parallel sides. And this was a lot like that other one we went over. where we have our congruent marks here in the middle, and I didn't change my color, but that's all right. So I know all the pieces of the diagonals are congruent. So that means that they're not only cut in half, but the entire diagonal was congruent to start with. Congruent diagonals mean rectangle. All right, so let's check this, and then we'll be all done with another one. Check, check, check. All right, we finished it.